Right, in today's video, I will try to attempt to explain, okay, how to find maximum minimum value of a given functions and the corresponding values of x. Right, so from part 1, if you can find the maximum minimum value of a given function and corresponding values of x, we can translate it into the minimum or the maximum point of the functions. Right, so let's look at this curve here. So this curve is y equals to x squared. So when you substitute x equals to 0, right, what you get for your y values will be 0 squared, which is 0. So that explains why the curve actually cuts through the origin. So we observe that x can be any real values. That means you can substitute x to be -1, -2, -4, -1.26, or positive 1.26. That means your x can be an integer, can be a rational number, can be any real numbers, right? Then if you look at the curve there, when you square it, you can clearly see that the curve is above your x-axis. That means all these are positive values, right? Positive values. It's above the x-axis, right? These are all positive values. Then below the x-axis will be a negative value. So your curve is exactly above the x-axis. So x squared will be always more than or equal than 0. So therefore, the minimum value of y is 0, as observed from the curve. And the corresponding value of x is 0. So if you look at the curve, the minimum point is 0, 0. Okay, now we extend this understanding to this curve where your y is equals to x squared minus 8. So you see now your curve is actually shifted 8 units down the x-axis. So therefore, your minimum value of y is no longer 0, but is actually -8. But the corresponding value of x is still 0. Why is that so? Because because to get -8, if your minimum value of y is -8, how do you get it? That is when you substitute your x to be 0, because 0 minus 8 then gives you -8, right? So where does this 0 come from? That means you actually let x squared equals to 0. So that's how you get x equals to 0. That's explain why when x is equals to 0, the minimum value of y will be -8. Right. So the minimum point will be 0, -8. There's another way of looking at it. Right. Another way of looking at it is for all real values of x, okay, from the first curve, for all real values of x from this curve, we can see that x squared will be greater or equal than 0, right? And if x squared is greater or equal than 0, right, and if you take away 8, then the minimum value that you will get will be -8. So therefore, your y, the values for y, will be more than or equal than -8. Hence, the minimum value of y is -8. And to get that, the corresponding value of x will be 0. Right, so let's look at another curve. So in this curve here, the function is equals to bracket x minus 2, close bracket squared minus 5, right? So let us start off by saying for all real values of x, your x squared will be more than or equal than 0 from the slide number 2, right? The curve that we have drawn. Okay, you realize that you can observe that the minimum value will be for fx will be 0. So hence for all real values of x, x squared is always greater or equal than 0, right? right, then bracket x minus 2 close bracket squared will be also greater or equal than 0. So why is that so? So we're going to do some substitution for you to explain why. Right, so when x is equals to 2, you substitute inside here, substitute x to be 2 here, you will get 0. Then when you substitute x to be negative 2, you get 16. Let x to be 3, you get 1, let x, so on and so forth. Right, so if you were to compare all the answers 0, 16, 1, you realize that the smallest value is 0. Right, so therefore x minus 2 squared will be greater or equal than 0. Okay, so what we're going to do now is we're going to subtract negative 5 on both sides of your inequality. Subtract 5, sorry, not negative 5. We're going to subtract 5 on both sides of the inequality. So when you subtract or when you add on both sides of the inequality, you don't have to flip your inequality sign off. So, right, we're going to replace this with your fx because your bracket x minus 2 squared minus 5 is actually your fx. So replace it with fx. We can clearly see that your fx is greater or equal than negative 5, meaning the minimum value of fx will be negative 5. So if you were to look at the number line, let me show you by drawing the number line. The number line is a very useful way of doing comparison. So we want to have anything that is more than or equal to negative 5. So the arrow goes to the right. So you see that the minimum value of fx is negative 5. So the minimum value of fx is negative 5. So if you want to get minimum value of fx to be negative 5, then what will be the corresponding value of x? So let's go back to your fx. So if you want this to be equals to negative 5, means this guys must be 0, right? Because 0 minus 5 then give you negative 5, right? So if x minus 5 squared is equals to 0, let's try to solve it. You square root both sides. So you square root 0, get 0. Add 5 to both sides, you get x equals to 5. So therefore, the minimum value of fx is negative 5 when x is equals to 5. Sorry, when x is, oh no, I wrote wrongly. Oh my god, I must be very tired. This is 2. The function is x minus 2. That is when x is equals to 2. So therefore, the minimum value of fx is negative 5 when your x is equals to 2. Okay, minimum value of fx is negative 5 when x equals to 2. So from there, how do we translate it to your minimum point? So therefore, your minimum point will be 2, negative 5. Right, so we've examined curve where the coefficients of x squared is a positive value. What happens if you're given the coefficients of x squared to be a negative value? So let's look at this curve f of x equals to negative x squared. So do you think this curve will have maximum or minimum point? Right, so let's start off by saying for all real values of x, right, so what happened? X squared will be more than or equal than 0, right? And if you multiply with a negative sign, what happened? Will you still be more than or equal than 0? Okay, let me give an example. We all know that 2 is more than 0. If I multiply 2 with a negative, Do you think negative 2 is still more than 0? No, now it has become less than 0. So when you multiply with a negative 1 on both sides of an inequality, then you have to flip the inequality sign. So in this case here, I have to flip it to be less than or equal than 0. Okay, so let's look at the number line. So we start off with the 0 in the middle. Then on the left hand side is negative 1, negative 2. Right hand side is 1, 2, so on and so forth. Right, so less than or equal than 0 means it goes this way to the right. Okay, so you observe that negative 2 will be less than negative 1 and negative 1 will be less than 0. So in this case here, what happened? What does negative x squared represent? Negative x squared represent your fx, right? So if I'm going to replace my negative x squared with fx, so can you see now that your fx is less than or equal than 0? So if your fx is less than or equal to 0, then we are saying that 0 now become the maximum value for fx. So look at this number line again. So fx now become 0 now become the maximum value of fx. So therefore, maximum value of fx is 0. Right, and what would be the corresponding value be? Corresponding value is 0 also, because 0 times 0 will give you 0. So maximum value of fx is 0 when x is 0. Okay, so therefore the maximum point will be 0, 0, right? So if you ask to find the maximum value of fx, then it will be 0, and the corresponding value of x will be 0. And if you ask to find the maximum point for this curve, fx equals to negative x squared, it will be 0, 0. Okay, let's look at a second curve. Okay, so your second curve, the functions will be fx equals to negative x squared minus 2. Similarly, we start off by saying for all real values of x squared is greater or equal than 0. Therefore, negative x squared will be less than or equal than 0. I'm going to subtract both sides. Subtract both sides with minus 2 on both sides. So if you subtract or add to both sides of an inequality, you don't have to flip the inequality sign. I'm going to replace negative x squared minus 2 with your fx. So in this case here, your fx is less than or equal to negative 2. So therefore, the maximum value of fx is negative 2, right? So maximum value of fx, I'm going to write it here. Right, it's negative 2. And in this case here, what do you think will be the corresponding values of x? When x will be 0, yes. So to get negative 2, I need 0 minus 2, right? 0 minus 2 then give you negative 2, right? So in other words, I need my x squared to be equal to 0. So x squared, negative x squared equals to 0 means x squared will be equal to 0. Negative x squared equals to 0 means x squared is equal to 0, and x will be equal to 0. So therefore, now the maximum point will be 0, negative 2. Right. Let's look at another curve. Let's look at the functions. So the functions given is f of x equals to negative bracket x minus 2 close bracket squared plus 3. Alright, so we're going to use the same concept as what we have done for the first two curves. We start off by saying for all real values of x, right, so our x squared will be more than equal than 0. and hence x minus 2 squared, x minus 2 to the power of 2 will be more than equal than 0 also, right? And if you multiply with the negative sign, you become less than equal than 0. Okay, so what happens if I add 3 to both sides? If I add 3 to both sides, the inequality sign won't change. Okay, so this is what happened. So if I'm going to replace with my bracket, I'm going to continue here. So replace with my bracket, a minus bracket x minus 2 cross bracket square plus 3 with fx. So we are saying that my f of x is less than or equal to 3. So can you see now that the maximum value of fx is 3? Right, maximum value of fx is 3. So therefore, maximum value of fx right. So what would the corresponding value of x be then? Right. So remember that to get f of x equals to 3, that is, okay, this is what we have. If you want it to be equals to 3, means I need to let this guy equals to 0, right? Because 0 plus 3 then give me 3. So if I let this equals to 0, and let's try to solve it. X will be 2. So therefore, the maximum value of fx is 3 when x is equals to 2. Right. So in this case here, we're talking about maximum point. So the maximum point will then be 2 bracket 3. Okay, so I hope this video helps you to understand a little bit on how to find maximum minimum value of a function and its corresponding values of x. If you don't quite understand the first time you see the video, please look at it a few times, and I believe you'll be able to find maximum or minimum value of fx of any functions